Good morning, everyone. Today we are going to start with the Unit 3 named as deadlock. And in the next slide, we'll see what are the contents of the deadlock. The deadlock chapter includes like system model, like deadlock characterization, methods for handling deadlocks, deadlock prevention, deadlock avoidance, deadlock detection, and recovery from deadlock. So now I'm going to start with the system model. So before that, I just want to introduce or give the definition of the deadlock. What is the meaning of deadlock? Any idea? I want to make it simple. So the deadlock is nothing but it is a set of blocked process, each holding a resource and waiting to acquire a resource held by another process in the set. The simple definition, a deadlock is a situation in which two computer programs sharing the same resource, they're effectively preventing each other from accessing the resources, resulting in the both programs ceasing to the function. Like in other words, like if two systems or two processes want to acquire the same resource, then what happens? The deadlock will occur. So I hope you all understood what is the meaning of deadlock. Now, next, I'm going to explain what is the system model. So what is the meaning of system model? System model is like, it is a part of the deadlock. Here what happens, the system contains the resource. The resources are like, we can mention them as R1, R2, go on unto up to Rm. But what is the meaning of resource in general? Resources are nothing but like CPU, memory, or input output devices. And coming to input output devices, you can include the printers, different types of scanners, etc. So these all will come under the resource types. So for this each resource, the operating system, the program or the process wants to access these resource types. Okay, so this is called as the system model. If the process wants to access this resource, first it has to create a request. Then after that, it can use the resource and then it can release the resource. Okay, while requesting the resource, if the process is available or if the resource is available, then the operating system will provide the resource to the process. Once the request is done by the process, or what is the process? Process is nothing but a program in execution. A program in execution is called as a process. If the process or if one program wants to request a resource, so first it has to send the request message. If the resource is available, then the operating system will provide the resource. Else what happens? So else if the resource is not available, then the request will be in waiting state. That is, the process will be waiting in waiting stage until the resource is available. Okay, so if once the resource is available, so next what happens? So the process will use the resource. It will use the resource means it will connect or it will produce the output in simple language. We can tell it as like it will execute the program. Execute the program means that is it will use the resource. Then next third step, after finishing the program execution or usage of the resource, then the process will release the resource. I hope you all understood. So this is nothing but a system model. So during the system model only, so sometimes the deadlock might happen. So if that, if the different process try to access the same process or same resource, then the deadlock will happen. So next we'll see what are the characteristics or how to characterize the deadlocks. So deadlocks can arise in any four conditions. So the conditions are, first one is mutual exclusion, second one is hold and wait, third one is no preemption, and fourth one is circular wait. So these are the four conditions or four characteristics. So which can arise. So if these four conditions doesn't arise, then what happens? The deadlock will never arise or it will never happen. So first we'll see what is the meaning of mutual exclusion. Mutual exclusion is nothing but, so at a time, so coming to our process, at a time, the process can use only a single resource. It can use single resource at a time. That is, only one process can use a resource at a time. No other, if already one process is in progress, then no other process can hold that resource. So this should not happen if the deadlock should not happen. So this is called as mutual exclusion. So second is hold and wait. Hold and wait is, as the name itself indicates, hold and wait. Hold is nothing but holding the resource and waiting for the other resource is called as hold and wait. See, in simple, a process holding at least one resource, the waiting to acquire the additional resources held by the other process is called as hold and wait. So that is, if the process is already holding one resource, it is executing with the help of one resource. But what happens, and the process is the same process which is holding the resource, it is waiting for the another resource which is held by the other process. Means it is not releasing the resource which is held by the process. So this is called as hold and wait, because due to this situation also the deadlock might occur. Next, third is non-preemption. So non-preemption. So in the previous classes, we have discussed about the preemption. What is the meaning of, what is preemption and non-preemption? The actual meaning of preemption is, I guess you all know that preemption is nothing but, so if the process is executing or using the resource, if the different process arrives to use the same resource, then the executing process will be in pause state and it will give the resource to the newly arrived or higher prioritized resource, higher prioritized process. This is called as preemption. In the simple way, we can say that, like if the prime minister is coming, I think I have taken this example many times in the class. We all are doing our work, like as usual work. Some people are walking and some are, driving and some are cycling. So on the roads, this is the roads. But suddenly what happens, the prime minister is, if he is passing the same way where we are walking or driving or cycling. So what happens? So the security people, they will ask us to pause for a minute or until the vehicles will move away. So until then, so what are the things we are doing? So we'll be just paused for a minute. And we'll be paused. And then what happens? Until all the cars will be passed, until then we'll be in pause state. And then once the cars are passed, the prime minister has moved away, our way. So then what we'll do, we'll start doing our like cycling, walking and driving. So this is called as preemption. So, and now coming to, I hope you all understood, and coming to the meaning of non-preemption. Non-preemption means nothing but if you're already performing some work, but even though some prime minister car is coming, but you're doing your work, you're not pausing your work. So that is called as non-preemption. So here coming to this deadlock characteristic. Here non-preemption is also one reason. So that might occur for creating the deadlock. So next is circular wait. The circular wait is, suppose for example, if there are different processes, that is P0 to Pn, you can take n number of the processes. The P0 has completed its work and it is waiting for it has completed its work. It has completed its works, but it is waiting for P1 resource also. So it is, I can tell it is not fully completed. P0 is not fully completed. It is partially completed and waiting for P1's resource. So that is the meaning. So there you can see the PPT also. Suppose for example, P0 is of waiting process such that P0 is waiting for a resource that is held by P1 and P1 is waiting for the resource that is held by the P2. So and so on. See, P0 has completed its half work, but it is waiting for P1's resource, and P1 also it has completed its half work, but it is waiting for P2 to release the other resource. Once the P2 releases the other resource, then P1's work will be easy and it will be totally finished. And P2, if there is P2, so P2 is it has completed its half work and it is waiting for P3's resource. So this is called as circular wait. So and if this circular wait situation arrives, then the deadlock might occur. Next, so these are the 4 situations which should not occur. So this might cause the deadlock occurrence. So first one is mutual exclusion, second is hold and wait, third is non-preemption, and fourth one is circular wait. So next coming to this is resource allocation graph. So as the name itself indicates, resource allocation graph. What is the meaning of resource? We have discussed in the previous class, like resource are nothing but if the process want to, or if the program want to execute, it will use or it will handle, it will make use of the resources. The resources are nothing but as I discussed earlier, they are CPU, like memory or input output devices. Okay, how the resources will be allocated to the process is nothing but resource allocation graph. With the help, if we draw this resource allocation graph, then it will be very easy for the programmer or the whoever is developing the program. So they can identify how to implement the program. So for at which time the process should allocate the resource. So because of this, the deadlock can be avoided. Not completely avoided, sometimes it might occur, but it will be avoided. And so here in resource allocation graph, so as we all know that vertices are called, they are represented as V and edges are represented as E. For the number of the process, like if the processor wants to allocate the, if the process wants the resources for execution, the process will be waiting for the operating system to allocate the resources. As you can see here, there are two types. First one is the process can request the edge, and second is the resource might be allocated. That is called as assignment edge. The request edge is nothing but it is a direct edge. What is the meaning of direct edge? Means the process is requesting the resource. That is PI. PI is nothing but process I. The process is requesting the resource J. Okay, and second one is assignment edge. Assignment edge is nothing but it is a direct graph. The assignment, as the name itself indicates, the resource J is assigned to the process I. So these directions are important so that with the help of the directions, if the any of the direction or the arrow is going from the process P to the resource R, then that is called as request edge. And any of the directed graph, it is moving from resource to process, then it is called as assignment edge. And so we'll see the graph. So and this is the continuation for resource allocation graph. See, if you want to draw the graph, so we have discussed like V are like vertices are represented with V and edges are represented with E and all. But so if you want to differentiate how the, what is the difference between process and resource in the graph? So if it is in circle shape, then we can identify that as a process. If the process will be in circle shape and the resources will be with like square shape. So I think you can see here, like the process are in circle shape and the resources are in square shape. Okay, and here's first one is process and second one is resource type with 4 instances. What is the meaning of 4 resource type with 4 instances? So the resource is represented by the square, that we all know that. And coming to the 4 instances are nothing but that small square boxes within the box. I hope you can see. So these are called as instances. In general, what is the meaning of instances? Instances are nothing but they are the different types of resources. Like CPU is one resource, memory is one resource, and input output devices are resource. Means that resource is holding the 4 subdivision of the resources. So this is the meaning of that. Okay, and next third point is PI request instance of RJ. So as I discussed in the previous slide, like PI, request edges, like if the process, the directed graph is moving from process to resource, then it is called as request instance. See here, as you observe in the diagram, so process PI, it is having the directed graph to the resource J. Means process is requesting the resource, that is it is having the resource contains how many instances or how many parts. It is containing 4 parts, means 4 different types of resources. So but process is asking for any 1 or 2 resources. So that is the meaning of the third point. And next fourth point is PI is holding an instance of RG. So PI is nothing but the process and RJ is nothing but it is the resource. So if you see, the first resource from the resource block is assigned to the process, and see the direction also, it is the directed graph is pointing towards the process, means this is called as like assignment. The resource has been assigned to that process. Okay, in the previous slide also, like we have seen, so it is called as assignment edge, you can see here. Okay, so if you see here, PI request instance of RJ means PI is in the request, it is requesting, and this resource is allocated or assigned to the process. Okay, so today we understood, like we have learned, like what is a deadlock, what is a system model, and what are the deadlock characteristics, and based on the what characteristics the deadlock might occur, and how to allocate the resources, to the process, and what are the like in graph, how to represent or implement the graph. Okay, next class I'll be coming up with a continuation class. Okay, and if you're having any doubts, you can ping me or you can ask me personally, students. I hope you all understood, and thank you so much.